Okay, so in a previous video, we were working on this problem, right? We needed to construct a box of a fixed volume, and we wanted to minimize the cost of the box, all right? And we left it where we needed to solve a system of equations, okay? So I just want to finish that up, solve this system. Okay, so here we go. Here's the system of equations, and we need to solve it. So, well, you just pick one equation and try solving for a variable if you can. And I think that the second equation right here is pretty easy to solve for x. Actually, solve for k. Solve for k. And in fact, that's often the case. It's not always the case, but it's often the case that you solve for the Lagrange multiplier. That's that letter that we chose, the variable that we chose to in this setup here. When you set the two vectors, when you say the two vectors are parallel, you say one is a constant multiple of the other one. This is the Lagrange multiplier right here. So it's often, you know, the best thing to do is to solve for that first, but not always. Not always. You really have to check things out. So let's take this second equation and solve for k. Well, I'll just divide both sides by x squared. So k is equal to 20x over x squared. So that's 20 over x. Okay. And now I think we can substitute this into the first equation. So just plug this in place of k over here, and then we can see what happens up there. So let's look at that first equation. So in place of k, I'm putting 20 over x. Well, these cancel. That's nice. So I really just get 12x plus 20y equals 40y. All right, we'll subtract 20y from both sides. And I can solve this now for, what should we solve for? Let's solve for y. So I'll divide both sides by 20. So, so y equals 12 over 20x, which can be simplified, of course. Divide numerator and denominator by 4, 3/5 x. Okay, so y is 3/5 x. Now there's an equation we haven't used yet, the third equation over here. So let's plug this in there, and then we can get a value for x, right? So plug that in up there. So we have x squared times y is 475, but in place of y, I'm going to put this. Well, this is just 3/5 x cubed. So x is 5/3 times 475 cube root, right? Now we can simplify this a little bit. I explored this ahead of time, and I noticed that this is divisible by 25. So 25 is 5 times 5. So we really have 5 times 5 times 5 as a factor of this whole thing. So that's 5 cubed, right? So you can pull that out, right? So this actually can be simplified by pulling out a factor of 5. And what's left over is a 19. So x is 5 times the cube root of 19/3. Okay. Now, how do I need to find the dimensions of the box. This is the width and the length of the box. I need to find the height of the box. Well, I can just go back up to one of my equations. How about this one right here? Y is 3/5 x. All right, so just use that to find y. Y is 3/5 times x, but x is this, so I'm just going to put that there. And then we simplify this a little bit. We find out that y is 3 times the cubed root of 19/3. Okay, so the dimensions of my box are this many centimeters on the base and this many centimeters high. So that's the solution to this problem.